example, it will be mixed. Okay, so now once you have it prepared, you place it here. So this is just to hold the sample. You can open them. It's better to always go as far as possible from the, now it's in the minimum, and also if possible in the smaller objective because it's farther, so you have more space to work. Then you secure it, and now with the joystick you can move it to put it under the objective.
Okay.
Exactly. More or less like this. And then we will focus with the Z.
Okay.
So we go live to see something. For now, we are really far from the sample, so it's normal that we don't see anything. So what we are going to do is to go closer. So zip up. And at some point, just take a look at both the screen and the sample, just to make sure you don't touch the objective. But at some point, we should see something in the screen. We go up. I can do this one and you can do the other one. See, at some points we have some fluorescence.
Okay.
Okay, so then we can go to fine.
Okay.
Because we are very close to the focus, so now we have to be very careful in the movement, so it's better to go fine. And then you can move it more slowly. And you can move up and down until you see some structure. You know, you see that if I go even closer,
It goes dark.
Exactly.
So we have to back.
So I go back, exactly, and I see the fluorescence. Now it is like saturated, we have too much light. What we can do is either to decrease here the laser power, or there's something called gain, that is like a digital multiplication of the light. So if we receive one photon, it will multiply it by 1000. So
which usually you're going to use? Reduce the power or reduce the laser? Or?
Usually the laser power should be around 20, 30, 40. So these values are okay.
Okay.
So then I would go with a lower gain in this case, because the values of the power are the normal ones. And also, if you see that here we have a white square, we are only decreasing the gain in this one.
Okay.
If you want to decrease the gain in the other channel, then you have to press. Now the white square is here, and then if you decrease the gain, it applies to this one.
Okay.
And this is always the sum of both.
All right.
Okay, so.
But I can use two different gains to make
you can use different gains, yeah, because they are different dyes and they act independent. They are selected already that they absorb at different wavelengths and they emit at different wavelengths, so they are completely independent. So okay, now if we go up and down, we can't really see much. We see that there is some fluorescence, but the thing is that we are at 5x magnification. We are only magnifying 5 times, and your droplets are probably very small. So now what we can do is to increase the magnification. So we go to the next one, 10x. And usually you have to adjust again a little bit the focus, but it should be close now. You shouldn't be very far from the real focus. So you can see the fluorescence immediately. And if I move up and down, I lose it. So now we are more or less in focus. But still we don't see anything because the magnification is not big enough for this sample. So we continue increasing. Just make sure you don't touch the sample. again adjust a little bit the focus, a little bit up and down. And the sample is more or less here. You can see it. You see that here the intensity is lower because it also depends on the objective. It collects more light or less light. That's related to the numerical aperture as well. So here you can increase the gain again.
Okay.
To have more or less good signal in the red channel and in the green channel. If you go up a lot, it's like saturated. So it has to be enough that you receive good light, enough light, but without saturating the image.
Actually, from these two slides, it's already contain a lot of fat and a lot of protein, is it?
No, we don't really know quantities with confocal because we are adding dye, so it depends on how much dye it's attached to the... Yeah, so you cannot really quantify. The only thing that you can see is distribution. And what we can see here is that this magnification, 20x, we can't really distinguish the fat from the protein. It's more or less homogeneous. So the droplet size has to be very small. It's quite homogeneous sample because it's the original milk. So now we have to go even higher magnification. And the next objective is already oil immersion.
Yeah.
So what we do is go to the middle space, put a drop of oil, just one drop on the cover slip. Is enough. And now, very carefully, you move towards the other objective. And the objective should be in contact with the oil. Can you see that?
Yeah, I can see it here.
And then, once more, adjust the focus. Come down until you find some fluorescence. In this case, we can't really see any fluorescence. I don't know if I am very far from the focus or if fluorescent. Are you here? Give me a minute. Yeah, but give me a minute. Yeah, so we are getting far from the sample, so what may be happening is that the gain is too low because we have decreased it for the previous objective. So what we can do is to go like to the maximum if you want, yeah, because it will be saturated, but at least we will see it and then we can adjust it. So we can go closer to the sample and at some point we should be able we're going very slow because it's the fine. Now all we see is noise.
Oh,
because
it's noise.
This is noise because we increased the gain to the maximum.
Oh.
And yeah, now you saw that we can actually see some structure. This is not noise, this is some structure, so this is your emotion. And if you continue going down, at some point you lose it. So it is good to go a little bit, penetrate a little bit in the sample because the cover slip will give some reflections like this. This is just reflection in the cover slip.
Yeah.
So if you go a little bit deeper, you will start seeing structure. But this is already, well, this is a little bit saturated. You can decrease the gain if you want, but you still see some reflection from the cover slip, so I would go a little bit deeper even, and at this point we can clearly see just the sample. You see the difference. So now you can adjust the gain a little bit. I would put a little bit more.
So they are the fat droplets.
Yeah.
What's the small thing? Are they
The
noisy?
small can be either noise. You can see by changing the gain that
okay.
you're just multiplying the number of photons. So there will be when you increase the gain, you're increasing also the noise. But sometimes you need to increase the gain to see the sample. So you can increase until you can see the shape of the droplets without increasing too much that you can see everything red, you know.
So,
yeah.
This one is homogenized sample.
Yeah.
So we will see we can see the protein surround the fat droplets, right?
Yeah.
So I'm going to reduce the gain of the protein as well.
You can decrease, but then you won't see anything really. So if you leave it like this, you can see, for example, this looks like a small aggregate, but they are really small. Okay. That's why you can't. So if you want.
So they are light.
Yeah, they are really, because it's the original sample. In your digested sample, you will see more aggregates. But this one, if you go to here, the zoom factor, for example, 4, you can magnify. This is digital magnification. You're not increasing the resolution, but you can see it bigger, and you can actually see how the protein is surrounding the droplets. See?
Wonderful.
Yes.
Oh, it's really.
It's really the
protein
is surrounding the fat droplet, stabilizing the motion. So the theory is true. And there are some small protein aggregates that you can see, but to have a good contrast between the two phases, I would increase a little bit the gain here.
Okay.
Like this, because then you can see clearly the protein, maybe even a little bit the light here. And now capture image. I pressed here, capture image, so now it's scanning, and this is your image. If you go to experiments, you have your first image, and then when you export it, the scale will appear automatically. So this, for example, you can measure this size. Is about 8 microns.
Okay.
It's more or less the fat.
Can we use another microscope? But I think it's good enough to see our fat droplets.
What do you mean? Another objective?
Yeah.
That's the maximum we have.
This one?
Yeah, this is smaller than this one.
Oh.
Yeah, that's the highest magnification. So once you come here, what I usually do is go again live. Let's remove this from. If you press here the arrow, you can remove it. So you can play with the zoom as well. This is the original zoom. This is 63 magnification. So you, for example, can capture an image. You can capture a different magnification, because with this one you will have a better picture of everything. You see some aggregates, some droplets, and then maybe you want to see the detail. So you can increase the zoom, go live, and take, and also you can move in the X and Y direction to see different regions of your sample. It's always good to have different images, because imagine you take the image just on the right spot where there is an aggregate, but the rest of the sample doesn't have aggregates. So it's good to take several images of different areas to check that your sample is really like that, is homogeneous. So I'm going to give my car keys to my boyfriend that is waiting outside. Yeah. You can just...
I go to prepare my another sample. I cannot wait to see my digestion.
Okay. So